All right, Brandon Clayton here, the Algebra Guy. So we've talked about solving systems of equations through graphing, through substitution, and now finally through elimination. So let's get into it. So again, we're talking about Technique 5C of solving systems of linear equations. What does it mean to solve it by elimination? So substitution works sometimes. Well, let me start with this first one. We have solved systems by graphing and substitution. Graphing works well when the coefficients are small and the solution has integer values. We talked about that. Substitution works well when it's easy to solve for one equation. And we notice that when you have a 1 in front of the variable or something small. But when you don't, elimination is ideal. Some prefer to just use elimination for that reason and go straight to the problem that they can solve. And here's a side note. I've noticed on SAT, they often are hoping and expecting students to be able to use elimination to solve systems. So let's get into it. This is what we'll do with the elimination method too, but we'll have a different way to get there and getting our answer. So and what I mean by this is we're gonna solve for one variable, just like we did with substitution, but we're just gonna go a different route. To solve a system by equation elimination, we start with both the equations in standard form. So I'm going to show you step by step what I mean, but I'm going to dictate it to you now. Then we decide which variable would be easiest to eliminate. How do we decide? We want to have coefficients on one variable opposite so that we can add the equations together. So notice how this works. So look at these two equations, this system right here. Now I have these two equations and I add literally, notice they're both lined up in standard form. X is on top of x's, y is on y's, and numbers are numbers. And then add 3 plus 2, plus y and minus y goes away to 0, and 5 plus 0 is 5. So what did we just do? We eliminated one of the variables by that's why it's called elimination. So if we were to solve that, we can see that x will equal 1. So that's how elimination works, is that we're going to take both of those equations, put them in standard form, and add them up. But we're going to add them in such a way so that one of the variables gets eliminated. All right, so this time we don't see a variable that can easily be eliminated. Look, if you were to add these up, it's going to end up getting 3x and 9y, and you're like, okay, this is not working. Well, now we have to manipulate it in such a way, or multiply it in particular, so that we can add it to have one of the variables eliminated. And in this case, if we multiply the first equation by -2, we'll get what we're looking for. We'll be able to eliminate the x. And just a reminder, multiplying the same thing on both sides of the equation does not change the value of the equation. Remember that from our properties of equality. So doing so, it doesn't change anything, just as long as you make sure you do the same thing on both sides. So if I multiply -2 on this side and -2 on this side, notice that's going to give me a -2x that I can add to this positive 2x and give me the answer I'm looking for, allow this to eliminate. So now I have -2x and 2x, and now that 2x and -2x goes away, and I'm just adding my y's to give me a -3y equals -4 and -2 gives me a -6. If I were to solve that, you'll divide by -3 to get y equals 2. And that's how you would do elimination. So if it's already set up where you can add it to eliminate something, take it. But if not, you can literally multiply the equations in such a way as to set it up so that you have opposites that will go to 0. All right, so let's try another one. What if you had this one here? What would you multiply to eliminate one of the variables? Now it's tougher to see on this one because we need to actually do a multiplication for both equations, because I can't just multiply by one number unless it was going to be a fraction that's going to eliminate something. So if I multiply at the top, if I multiply by the first equation by 3 and the second equation by -4, I'm going to get 12x and -12x. So that's going to give me an opportunity to eliminate those x's. So here's what I'll do. Multiply this top by 3. Notice this whole thing is by 3. And this whole part is by 3, and then -4. All of this by -4 and all this by -4, because that's the property of equality, just so that we don't change it. But that's going to give me a 12x and a -12x, which is going to allow those to eliminate, leaving me now with just my y's that I'm adding up. -9y and -20y give me a -29y. 30 and 28 gives me a 58, which is easy to divide to a -2. So y equals -2. So this is another way, like substitution, of isolating only one variable so we can solve for that one variable. Then we'll again place that answer into the equation to get the other variable. So in this case, it'll be placing -2 in for y and solving for x. All right, now let's see how we can use elimination with a problem that we used when we did substitution. So looking at this, we want to eliminate one of these variables. I could eliminate the y by simply multiplying this whole part by 2, because 2y minus 2y is going to be 0. Or I could eliminate the x's by multiplying by -2, because 2x minus 2x is 0. I'm going to do 2 to eliminate this one. I'm going to multiply this by 2 and this by 2. So that's going to give me 4. Let me make sure I write 4x, because when I distribute here, 4x plus 2y equals 14. And I'm going to keep the same equation because I need not alter that in order to eliminate. So this is going to be x minus 2y equals 6. Now when I add these together, watch what happens. So I end up with 5x, this goes to 0, and I'm left with 20. Now I can divide by 5 and divide by 5 to get x equals 4. Now I'm not done, of course, as you know, because we need 2 coordinates to make a point in where they're going to cross. So let's plug this 4 back into the equation to figure out what that equals. I'm going to plug it back into this bottom one here. So x minus 2y equals 6. So in place of that x, I'm going to put a 4 minus 2y equals 6. Solving for y, let me subtract 4 first. Subtract 4. And there's nothing there. -2y equals 2. Divide by -2. And y equals -1. So now I know my coordinates, 4 and -1. And I could have used this equation also to check that answer, as I've talked about before, so it didn't matter. And matter of fact, it may be a good idea if you're feeling it at all a little bit that this may not be the right answer, you just want to double check. Here you'll know for sure. So let me go ahead and check it. So 2 times 4 is 8. 8 minus 1 is equal to 7. So when I place my x and y back into this equation, it does equal as it should. So we know that that's the solution. All right, let's move to our next problem. So we'll do an example first where it's easy to eliminate, right? So which ones should we eliminate? The x's or the y's? I'm hoping you say the y's, right? Because you can see that plus y and negative y are going to add up to get 0. So x plus x is 2x. This is going to give me 0. 10 and 12 gives me 22. Dividing both sides by 2 leaves my x by itself. And I'm left with x equals 11. So that's one part of the coordinate now. So I have 11. And now I need the y coordinates. So just plug 11 back into either one of these to get your answer. So let's say we'll plug it into this one. So we'll plug 11 in here plus y equals 10. So what does y have to be to get 10? Well, I have to subtract 1, so that's going to be a -1. There you go. In this example, we'll be able to make the coefficients on one variable opposites by multiplying an equation by a constant. So we can just multiply 1 by a number to get opposites this time. What should you multiply? And which equation will you multiply by? So the one I would choose to make this easy is I noticed that 2 and 6 are almost going to eliminate if I can just get this 2 to become a 6. Well, I could just multiply by what? A 3. In this case, a -3, because a simple 3 would keep it negative and it won't eliminate. I need them to be opposites. So I'm going to multiply both sides by a -3 in order to get this to become a +6. So this is going to be a -3. This is going to give me, when I distribute, -3 and 3 is going to be -9x plus 6y equals 6. And I'm going to leave this equation the same. 5x minus 6y equals 10. All right, so it should be easy to add these up. -9 and 5 give me a -4x. Adding 6 and -6 are easy just to cancel. Now I'm left with 6 plus 10 is 16. Dividing both sides by -4. And I'm left with x equals -4. plugging my x back in to find the y value, I will choose, let's choose this top one. So I'll do 3x minus 2y equals -2. But I'm going to plug in for x -4. And now everything's in terms of y. 3 times -4 is -12 minus 2y equals -2. Getting my y by itself, I'm going to add 12. And that leaves me -2y equals 10, dividing both by -2. Y equals -5. So now I have both my coordinates. X is -4 and y is -5. That's the point in which both of those lines are crossing in what we call the solution to that system. All right, now we'll do one that's a little bit more, requires a little bit more work because we need to multiply both equations by something in order to get rid of a variable. So you can choose what you want. You can do 4 and 7 and try to get 28 and -28 by multiplying one by 7 and one by a -4. You could do 3 and 2 and get 6 and -6. I'm going to do 3 and 2 because it's smaller numbers. So I'm going to multiply this top one by, let's keep that negative, and I'm going to multiply this by 2 though, everything up here by 2, and I'm going to multiply the bottom. In order to get this to become a 6, I'm going to multiply this by 3. So I'm trying to eliminate my y, and 2 times -3 is -6, 3 times 2 is 6, so -6 and 6 will cancel. So let's see what we get. When I distribute here, I get 8x minus 6y equals 18. And distributing here will give me 21x, and again 6x, or 6y, sorry, and a -18. Now I'm able to add everything up. 8 and 21 will give me 29x. These are canceled, be 0. 18 minus 18 is easy, it's 0. So now I have dividing by 29, I get x equals 0 divided by 29. What's 0 divided by 29? Well, it's going to be x equals 0. Now, that number will throw you off, right? It'll throw a lot of students off because you're like, this is the weirdest answer. I'd rather have a fraction that says 2 over 29 than 0 over 29, but 0 is an answer. Don't hate on the 0. That's still a number, and we need to keep it as such for this answer. So let's leave it just like that. All right, now that we have our x coordinate, so I'm just going to write this somewhere. Let's put we know what our x is, 0. This is a 0. That's an answer. That's a real coordinate. That's a real number. Let's plug it back into either one of these equations. I'm going to pick the bottom one just to change it up. I think I picked the top one last time. So 7 times 0 plus 2y equals -6. That's going to be 0 here, so I'm left with 2y equals -6. Y will equal a -3. Because 2 times -3 is 6. So now I have a -3. And if you were insecure about, is that right? And I get that way because I'm always wanting to double way to check. Just put the 0 in the other equation. So if I put the 0 here, then that's 4 times 0. This goes away. I'm left with -3 times something gives me 9. Well, -3 times a -3 gives me a positive 9. So now I know for sure that this is the solution. All right, when a system of equations contains a fraction, we'll clear that fractions by multiplying each equation by the least common denominator. In this case, we have 1/2 and 2/3. The least common denominator is going to be a 6 because 2 times 3 is 6. And I know that that's the least common denominator. So I'm just going to multiply both by this 6 to first get rid of these fractions because let me write this better. Let me do this side with times 6, this side times 6. All of this times 6 and all of this times 6. Because we have 2 and 3 as denominators, 6 will get these to all have integer numbers. So 6 times x gives me 6x. And 6 times a half, half of 6 is just 3y. Equals 6 times 6 is 36. And here I got 6 divided by 2 is 3. 3 times 3 is 9. So this is 9x. 6 divided by 3 is 2. 2 times 2 is 4. So that's 4y. And 6 divided by 2 is 3. 3 times 17 is something I got to work out. So 1, 2, that's 51. All right, now we have to start with this one. So we had to do that just to get to this place. Now we want to look to see what we can eliminate. I'm going to pick the smallest numbers. I'm going to get 3 and 4 to eliminate by taking it to 12 and negative 12. I will start by multiplying this top one by a 4 or a negative 4. And this bottom one by a 3. So let's make sure that's right. Negative 4 and 3 give me a negative 12. 3 and 4 give me a positive 12. So I'm going to eliminate my y's. All right, so rewriting that will give me negative 20. So distributing here will give me a negative 24x minus 12y equals, what's 4 times 36? Let's work that on the side over here because I don't want to take out my calculator. 4, 2, 12, 13, 14, 144. It looks like I'm eventually have to take out my calculator though because these numbers are getting rather large. All right, 3 times 9 is 27x, and 3 times 4 is that 12x or 12y that I was looking for. 3 times 50 is 50 times 3 is 150, plus 3 more is 50, 153. Now, let's see if this helps us. Negative 24x and 27x is a 3x. These cancel. And I'm left with, okay, this is not too bad. The difference is 9, it looks like. So we got a 9. Hey, that worked out pretty good. Dividing by 3 gives us x equals 3. So now I know what my x coordinate is. It's a 3. To find my other, I can plug it back into the equation. Any one of these will do. So I'm going to choose the one with the not so many fractions. I'm going to choose this top one here. I'll choose the x plus 1/2 y equals 6. So I'm going to plug in 3 right here for my x. 3 plus 1/2 y equals 6. Subtract 3 on both sides. That leaves me with 1/2 y equals 3. Multiply by 2 to get rid of this fraction on both sides. 2 times 1/2 is just 1. And 3 times 2 is 6. So there is my y value, 3 and 6. Now, as a side note, I want to show you one additional way to solve these equations. I'm adding this video actually later because I want to make sure you have the full suite of tools to use. We talked about graphing, substitution, elimination, but you can also use your calculator. I've shown you how to use your calculator for graphing, but there's other features in your calculator that will allow you to solve systems, namely the one I'm about to show you now. So if you go to your calculator here, you go to your calculator screen, we go to Menu, Algebra, and it'll actually be a link here that says Solve Systems. So we're going to click on Solve Systems of Equations, and we have 2 equations using x and y. If you had different letters there, different variables, you could put those. But I'm going to just put it up this way. And all they're asking you to do is type in the equation just as you see it. And make sure I put that in right, because that'll be the only problem I have here, because the calculator knows what it's doing. But I got to make sure I do it right, my part right. So I'm going to press enter. And look, 3, 6. You're going to get the same exact answer as if you've done it in a different way. I know it's so easy, it feels like cheating, right? But it's actually a tool that the calculator provides. So if you want to double check your work or start off that way, you could. So we've done it. We've solved systems using graphing, substitution, elimination. Now I've shown you how to use the calculator features to do the same. All right, in solving a system of equation by graphing, we saw that not all linear equations have a single order pair. When the equations are really the same line, there are infinitely many solutions. When 2 equations describe parallel lines, there was no solution. So if they're the same line, infinite solutions, different lines, but same slope, they were no solution. Let's solve this one in light of what we just said. First of all, before we can do this with elimination, what must we do first? Yeah, we got to get both of them in standard form. So this top one's already in standard form. Right there. I want to get this in standard form. I need to add 3/4 x on both sides. So 3/4 x on both sides. and that's plus y equals a 3. Now I have a problem because standard form doesn't like to have a fraction, so I need to do one more step and multiply this by a 4. I'll multiply everything by 4 here. So this top is going to stay the same. We're good with this one so far. 3x plus 4y equals 12. But I do need to change this. So 4 times 3 fours. These 4s are going to cancel. 4 divided by 4, and that leaves me with 3x. Actually, I could have almost eliminated right in that step, looks like, but I'll take it one more step further so you can see. 4y equals 12. Okay, that's what I want to show you. Yes, look at this. What do you notice? They're the exact same equation. So please work no further. Know that they're the exact same line. So if we were to graph this and they were in the exact same line, you know that every single point is going to be, they're going to share. So we have an infinite number of solutions. Infinite solutions to this one. So just from here, now if you start trying to solve it, everything's going to start getting eliminated, and you may end up with like a 12 equals 12 or something like that. But we don't have to go any further. They both equal right there. All right, let's do this one in the spirit of what we just discussed with like slopes. What do you think is going to happen here? So they're both already in standard form. I do notice, however, that 6, 15, and 10, maybe I'm wrong. Let's see. No. Yeah, I'm wrong. So it looked like that could factor out something. So I was going to try to, but I can't. So let's see if we can eliminate something from these two. And I'm thinking these have the same slope, but I'm going to eliminate either way. How could we eliminate from this one? So we could either multiply this by a 3. Actually, multiplying by a 3 is going to get rid of everything, both the x and the y. Because 3 is going to make this a 6, which gets rid of negative 6, and negative 15, which added together to 15, will go away, and all we're going to have left is 0 equals a negative 15. So you can already see that, but I'll go ahead and write it out in case you can't. So negative, let's see, actually just the bottom is what we need to multiply by. So if we multiply by a negative 3, no, just a 3. So we just multiply by 3 on both sides. This is going to give us negative 6x plus 15y equals 10. So that stays the same, right? But this is going to be a 6x and negative 15y equals negative 15. So notice that everything here is starting to look very similar. Now when I add these together, like I said, this is going to be 0, this is going to be 0. So all this is just going to be 0. And we add these together, we end up with a negative 5. So why did this happen? This happened because when you write out these lines in slope-intercept form, they have the same slope but different y-intercepts. So this is going to have no solutions. These are never going to be equal, as opposed to the other one that was always equal. These are going to have no solutions at all. All right, so summing up what we talked about. When do we use graphing, substitution, and elimination? Graphing is nice when you need a picture of the situation to see what's going on. So when we did inequalities in particular, when we're shading, we need to see. Or if you just want to kind of get a visual of where the points are crossing. Substitution, when one equation is already solved for. If you have one that just says y equals 3 or 3x plus 2, or x equals this, just go ahead and take that and substitute. Elimination is when they're already in standard form. Oftentimes it's easier just to add them up to see which ones can eliminate. And that's what we did here. Guys, thanks for tuning in. My name is Brandon Clayton, the Algebra Guy, and I will see you next lesson.